All right guys, welcome back. We're about to start our hands-on training exercise. Before we really dive into that, I do want to make a quick note about this article that we have here that has a lot of helpful information getting started with LP360 and much more. So for any of you who have just installed LP360 and you're just starting out, we do have this general information about how to manage your licensing, how to get installed, all that good stuff, as well as navigating LP360, all the processing that we're discussing today, all the field checking that we did yesterday, and much, much more. So basically everything we touch on in today's session will also have full documentation here at this page. And with that, we're now going to open up our LP360. And we're going to do a review of our license manager and our project settings like we did yesterday, just to verify all that information is in place and make sure it is fully documented as well. So the first thing we're going to do is open up our license manager. We're going to go into our license manager. We need to make sure that everyone has their licensing. So you should have a drone floating license checked out at this time. That's the one we're going to be needing. If you do not have one yet, you may need to go into your credentials, sign in with your username and password for LP360 online, and you should see your perpetual string populate. From there, you should see any licensing that you have available at your disposal here, and we're going to check out that drone floating. Does anyone have any issues getting their licensing? Okay, everyone has the licenses. All right. So we're now going to close this dialog. And like I said before, we are going to review our settings. We're also going to review our archive manager again, just so that everything is covered twice for our material yesterday for the sake of repetition. So first off is our default project root folder. This will be the location that all of your projects will default to versus you having to go search and find a location. So if you are working on a specific project or project area, you could create a folder for that and all of the LP360 projects you create following setting this up will be starting in this folder location, and it can be changed at any time. If you are a CAD user and you would like to inverse your mouse wheel, go to the Global tab and change it here. You will modify that to enable that inverse mouse wheel. We also want to make sure that we set up our notification email. This is very important. This is the email that is used if you ever experience a crash in LP360. You will notice that my email here and the one I am signed in with are not the same. That's because this particular email is the one that will be used when it crashes because you will no longer be connected to your licensed server. It is not able to pull down that email, so you do need to enter it in here. If we experience any crashes today, you will see what I'm talking about. If you're using sensor processing for multi-cycle processing, you will want to make sure you set up a working directory. This is a location that you specify on your machine that you would like data stored temporarily while it is being processed, and then it will be exported out. Finally, for today's exercise on the EXP tab, you do have your pyramiding settings. We do want you to stick with the LP LAS. But I prefer to have mine set to backup because I always like my original data to be stored for me to revert back to. But for those of you that may be worried about bloating your projects or having too much going on, you can change it to the overwrite function. Okay. And with that, we're going to move on to our archive manager. So on to the sensor tab. On the sensor tab, we're going to go to our archive manager, and we're going to discuss the options here. So yesterday I discussed how you can set up an archive anywhere you would like, including a server location, and you can actually move your data sets around. So yesterday I created this training folder for our 2 cycles that we collected during that session. Now what I'm going to do today, instead of creating a new archive and importing to archive again, I'm actually going to show you some other functionalities with this. So for example, let's say I create a different location. I'm just going to put it somewhere on the top level of my folders here. So I'm going to create a new folder, And I'm going to call this December day 2. You guys do not have to do this part. This is just for example purposes. So December day 2, it is in a different location than my existing one here. And I'm going to call this one, for the description, December 2025 day 2. Okay. When this creates, you will notice it is entirely blank. There's nothing in it. So let's say yesterday my pilot archived these 2 flights for me on their machine, and I want them to push it up to a server location, which is my example one here. Instead of having to archive for a second time, what they can do is select both of these cycles here and click copy or move. In this case, I want to click copy. It will actually allow me to select a different archive location. So for instance, these are my servers, but we're going to select my sample location down here. Click OK, and it will actually copy those over to that new folder location for me without ever having to leave this dialog. And remember, this tool is utilizing what's called robocopy. So it is doing an integrity check of my data before and after to ensure no corruption has occurred. So now if I scroll back down to that new folder, you'll see I now have both of my archived flights inside of that one. Okay. Does anyone have any questions on the Archive Manager? How you can use it? If you decide to use the move function, so move, it will actually delete them out of the existing folder, which is why I used copy, so that they would remain. All right, and with that, we are ready to import. So we are now going to go back to our sensor ribbon, and we're going to locate the cycle import button. The cycle import button. Now, since we already copied our archive to a new location, I'm going to click import my flights on the next page, but this time I am not going to use my folder to locate that. I'm actually going to go into my Archive Manager and pull down those archived flights. So in my Archive Manager, I'm going to go to the one that I just copied over. So here's my 2 flights. I'm going to select both of these and OK. It will ask me if I would like to decompress these. The answer is yes. And it will begin that process of adding them and decompressing them to this dialog. Now remember, yesterday we talked about this little yellow icon. It is not an error. It is telling you to read me. It is a warning saying, please review my information. In this case, it is letting you know there is an updated firmware available for your payload. So maybe you might want to update that after you process these cycles. So it will appear for each cycle that occurs. That's okay. That's what I want. And now I want you to notice it already has that information from my ancillary files that I added yesterday. Yesterday I added these for my control points. So if I double click there, you'll see all the different files that were added. So that's the benefit of archiving these with those ancillary files, so that whenever you import from your archive, you will have all that additional information. You do not have to go locate it again. Okay. On to our next page. You'll also see my base stations have been fully imported. These were the ones that were stored along with that archive as well, and it brings those in for me here. Is anyone not seeing their base stations? On to our next page. This is where we actually set up our settings for the project itself. You can see where it's pulling down my default project root folder. This is the one that is specified in my project settings. You're more than welcome to change this if there is a different location you would like to use. However, I like to use my default root folder as often as possible, just to simplify my workflow. Now for my output name, remember we want to keep it short and sweet, and we also want it to be something understandable. So since it is in my December training folder, I'm going to call this my day 2 in person. So yesterday I had the day 1, this will be my day 2. So that way I know exactly what I am working in. Now, just like yesterday, we are going to review all the options for our coordinate systems. As a quick note, I know that I am a little repetitive in these steps, but it's because I want to make sure that this information is, 1, documented, and 2, makes sense to everybody. So there are multiple options here. So if you ever add in a coordinate system, so I'm going to pick a random one that you no longer want in your drop-down list, click that X button, it will be removed, and it will go blank. In the select dialog is where you can specify what coordinate system you would like to use. So inside of this, you can either use the plus buttons next to the folders to navigate to your folder of choice. We typically recommend using the NAD 83 2011 datum. As a quick note, you'll also notice there is a green verified check mark up here. This is to indicate that it has been tested in our software and does function appropriately. You also have the ability to search for your authority code. That is a unique code associated with the horizontal coordinate system. For today's exercise, that will be 6355. 6355. And you will notice these are colorized in green. For our colorblind individuals out there, you will also notice there is a check mark here on the icon. If it is unverified, it will be blue, and this check mark will not exist. It will just be the little circle icon, okay? If you would like to find the authority code for your own coordinate system, you will scroll to the bottom, and it will be the last authority code listed in the horizontal description. There is no authority code associated specifically with the verticals, okay? For our vertical, we are also going to choose the ellipsoidal meters, because that's what we're processing in, is meters. So make sure you don't mix the coordinates or the units, as this can cause issues in processing later on. You do also have the ability to select from a file. So for instance, if I click Save PRJ, it will save a file for me. I could provide it to a colleague, to a client, someone that needs my coordinate system, and they could use this Select from File option to just import this entire coordinate system. Click OK here. It will be added in for me to use. And on the next page, I can just verify the details of my import. I shall now pause.
Which vertical data do we want?
Ellipsoidal meters. And the authority code for the horizontal is 6355. Yep, that number is ingrained in my brain. All right, now that we have verified our details, because we can see our base stations here, one of our flights actually has 2, whereas the second one only has 1 that covers its time frame. That's perfectly fine. We're going to click Finish, and it will begin the import process. When you see this confirmation dialog, it is just asking to confirm that you would like to create this new project folder along with its XML. The answer is yes. All right, once your cycles have imported, you will see 4 unique shape files that are included. That's going to be your photos, your trajectory points, your log points, and your trajectory line. For processing purposes, we are only going to be utilizing the trajectory points. So to start off our processing, we are going to use the Auto Create Flight Lines tool. Now keep in mind, when you are looking at this ribbon, you are going to move from left to right in your processing. So inside my Auto Create Flight Lines, we're going to start in compute mode, and that's where we have these 3 different parameters. Now again, the first one is our minimum length. This is going to be the shortest desired flight line that can be estimated in your map view. So for example, if I did want to measure one of these lengths, I can use my measure tool here. Now I do like to pause my functionality in the middle just to kind of show how this works. So for example, if I draw down here and I click and then I try to look over here, you'll see that it continues to track me everywhere I go. So let me reset that. So I'm just going to click my pan, kind of click around, get it to disappear over here. Do measure again, click once, and then I actually right click at the bottom of wherever I'm trying to measure. It will pause the functionality, and now I'm free to go look down in the bottom left-hand corner to identify that length. So this is roughly 97. So I'm going to stick with my 90 length here, because remember, you are going to be trimming away from those turns, so it is going to be a little shorter. So whatever you measure, you do want to round down a little bit to make sure you're not cutting out any of your flight lines. Okay. The turn radius is how much it's going to trim away from the detected turn. So typically that's going to be wherever it actually changes its orientation completely, and trim away from there. And then our maximum deviation, this is if it deviates up, down, left, or right by this number of map units, in this case 10 meters, it will break that into 2 flight lines. So if you are following terrain, you do want to make sure to increase that number to compensate for any changes in altitude. So for now, we're going to stick with our settings of 90, 3, and 10, and we're going to click Compute Flight Line. Now I can run this as many times as I would like, so if I did want to change any of my parameters, so for example, if this minimum length is not working for me, maybe I want to give 100 a try, I can run that. You should see that it's going to remove some of my flight lines there. That obviously doesn't work for me, but it's as simple and as quick as that. You can run it as many times as you'd like. On to the next page is where we enter edit mode. Again, it will automatically enable your select tool. Mine is set to lasso. If you would like to change the type of select tool you have, you can go up here to the ribbon, click the drop down, and specify the one that you would like to use. I just like the lasso the most for my purposes. Now to be able to visualize these flight line layers a little better, I'm actually going to turn off my Google Hybrid, so I'm going to turn off my base layer. And we can see there's this little curve down here. Now realistically, this might not impact my data, but for today's exercise, I'm going to recreate this flight line without this curve. So I'm going to select my flight line, it will highlight in blue, and I'm going to use the delete and enter key on my keyboard to remove that. Now, to begin creating a new one, I'm going to go into my table of contents, find the flight line layer that is turned on, and look directly below it. That will be the trajectory points file. We're going to enable that, and we're going to use this to create our new flight line. So select a point at the start of the line, hold the control key, and select one at the end of your line. Once you have 2 points highlighted in blue, click the manual flight line button up at the top, and a new line will be created. Now I'm going to do this same process on our next flight. So I'm going to click here. You will notice that it populates with that other flight line layer. Again, we only want to keep these nice straight lines. We don't want our transect lines flying out and from our mission, as these can have changes in altitude, changes in speed, changes in dynamic movement that can cause our points to be very irregular in those areas. So we don't want to include those in our last point cloud. So I'm going to select, delete, enter. And now for the sake of this exercise, because we can see we have another one up here that has a little curve on it, I'm also going to recreate this one. So again, select, delete, enter. Go into my table of contents, find that flight line layer that is turned on, enable the trajectory points just below that. Okay. I'm now going to select one point at the start, hold the control key, select one at the end, and click the manual flight line button. And just like that, I have created my desired flight lines. You will now see the status is set to edited, and I am ready to move on to my next step. I will close this dialog now. Is everyone able to follow? Is anyone lost? No? Okay. All right. So our next step is then going to move into our sensor processing. Now, if you had only a single flight line or single flight, you're more than welcome to use the trajectory and geocoding steps completely separate. But in this case, since we do have multiple cycles, we want to configure all of the settings at one time. So we're going to go into our sensor processing. Remember, this does require that working directory is set up in your project settings, and it requires the unlimited license for multi-cycle processing. Now on to the next page. This is where we're actually going to configure our settings for our trajectory points, or trajectory processing. Um, Yours says it doesn't have the unlimited, and you're in the training account.
Yeah, I'm supposed to do.
So we now have our sensor processing dialog open. This is where we can configure and set up our trajectory processing settings and our geocoding settings for all of our cycles. So on my next page, this is where I configure my trajectory processing settings. You can see here under status, it is waiting for me to give it a valid base station location. Now, if I had multiple cycles here that may have been collected over a series of days, let's say I was at the same project area for 3 different days and I had several flights. You don't have to add your base stations individually here. You can actually click the base station observation files here and dump as many as you need into this location, even for multiple days. LP360 will then parse this information and identify which base station file goes with which cycle. Okay? From there, you can then click the settings icon to modify the survey nail. So this would be the location of the base station. Now for this next moment, you guys can just pause. I am going to talk about some of the settings here. So yesterday we ran the QC only real time. So that's what you do when you're out in the field to verify that you had a successful data collection. Now single base is used if you have your own base station file that you have collected or you may be downloaded from CORS, and it requires that survey nail information. The paid services, however, is going to be the Smart Base and the PPRTX. Again, if I click Smart Base, since it is a paid subscription, you should see my cost estimate will be modified based on the time of flight. Now this is based off of the CORS network. So if you are in those rural environments where you may not be near a CORS network station, you will likely want to use PPRTX as it has 100% coverage in the continental US. Okay? So that's a way you can estimate those points if you needed to buy this as a backup if your base station was corrupted or something of that nature. Now additionally, we're going to talk about our cycle summaries down here. So you can actually see your sensor model. So that's the type of sensor that you have, your serial number, the way the hardware is configured for processing. So that's a quick way to see where that is. This one is configured for the cloud, so it is only allowed to be run through the cloud. And you can see the start and end time of your flight. Okay. On to our next page. This is where we actually set up our survey nail information. You can actually see it selected only that one base station file that I needed. And now we're going to create a new survey nail. As a quick note, if your base station has run for more than 2 hours and it is a Trimble type rover that was used to collect this, or base that was used to correct this, you can use the Trimble Centerpoint RTX. Again, it must be running for at least 2 hours and it needs to be some kind of Trimble model base for that. Now, under my survey nail icon right here, for those of you that may be using an older version of software, it will look like 2 little nails crossed over each other. I'm going to click that, and you will see every coordinate or every survey nail that I've used. Now again, you can add new ones, you can clone one that already exists, you can edit them, you can delete, and you can actually import and export survey nails from here. So if you needed to provide them to a client or a colleague, you can do so. For today, we are going to create a new survey nail. So we're going to click Add. And we're actually going to load from Opus. So if you remember yesterday, I gave you a set of folders. One of them was a base folder. That is going to contain the survey nail that we need via the Opus report. So it'll say Opus_report. Okay. So I'm going to click that there. We're going to go find our training folders, and yours should say December training, and you're looking for that base folder. Is everyone able to locate that? Okay. Inside that, you should see that Opus_RPT. Now Opus, when they provide you this information, your base station is sent off to them. They will review the information. They'll send you an email with this information, and then you copy the email and paste it into a text file. It doesn't just come to you in a text file, okay? So I'm gonna click open here, and it will populate with the latitude, longitude, and the ellipsoidal height. and it will also populate with the frame and epoch or epic, however you prefer to say that, of when this was collected. Now you can give it a name and a unique description, so I'm just going to call this one Day 2, or I'll call it December Day 2, because I do have many base stations here. And then I'm just going to say, for my description, because you can enter in as much as you would like, I'll just say December 2025 in-person Day 2 training. So now I know exactly what I collected and used this base station for. So click OK here. It should add it to your list. You can see mine right here. Once you do that, you can click OK, and it will import all that information. All right. Now our base station does include our antenna height in the height of the base station itself, but if yours does not, you will need to add the height of your antenna. This will be in meters, so this should be a small number because your antenna is typically only going to be a couple of inches tall, typically. Okay, so do keep that in mind. On to our next page. This is just where you verify the information. This internal section will not appear when you're working in your own projects, in your own offices, but since you are using our training account today and I am one of our internal users, this will appear each time I try to execute this. But you'll see the hardware type, the run location, and the processing mode, which is single base. Additionally, if you did pick one of those subscription-based options, so Smart Base or PPRTX, you would also see that cost estimate before submitting. All right, once I've done all that, I can click OK, and it will store those settings. So just a moment, and you'll see that status has modified to edited. Now, since these were collected in the same location, I'm actually going to paste my settings into this other flight. So I'm going to click copy, select my second base or second flight, and click paste. It will ask for confirmation that this is what you want to do. In this case, the answer is yes, and it will modify those settings automatically without me ever having to open that dialog. Okay. Now we're going to move on to the next page of this dialog, and you guys are more than welcome to just sit and watch. I'm just going to talk about some of the settings we're going to see here. So you'll see that by default it does enable our clip angle. Remember, for most TrueView units, we recommend using 40 degrees. However, if you are using that TrueView 540, you may want to decrease this down to 35, or you'll get uncolorized points because the field of view and the field of view for the camera and the laser are different. Now, as I mentioned, you do have the ability to update your EXIF tags and colorize your point cloud inside of this setting. If you would like it to run a little faster and colorization is not of importance to you at this moment, you do have the ability to update your EXIF tags and colorize outside of this tool, but it can only be done to the geocoded LAS dataset. Okay. So I'm going to click OK here. You will see this little pop-up. It will happen pretty much every time you do this. Again, these little blue icons, it means to stop and read me. Now what it is telling me is that there is a calibration file that is more recent than the one that is on my payload. And it's asking me if I would like to use this up-to-date file. In this case, the answer is yes. You will see those settings have been changed to edited, even though I didn't actually change anything, because I did tell it to use a new calibration file. When I click submit, it will submit the trajectory processing jobs all first, then our geocoding, and it will ask me to confirm that I do want to use that up-to-date file again. In this case, the answer is yes. I can then open my job manager, and we can see those processing. Now, unlike yesterday, we are processing through the cloud, whereas our QC processing does on the computer. The difference here is yesterday we could only run one at a time because we were processing on our machines. Since we are using the cloud, our trajectory processing can actually run in tandem. So we can do multiple at the same time, which is where this sensor processing, multi-cycle processing comes into play and is very beneficial. So now we wait for our jobs to finish. Also, I really hope these are successful. All right, it looks like our first trajectory processing nope, redo that. It looks like our first trajectory processing job has completed, so we're going to go ahead and start reviewing that report. You'll also notice that the geocoding job following it has already begun its process. So I'm going to select my ready task. If yours is not ready, that's perfectly okay. We're just going to review this report while we're waiting on the other. So I'm going to click complete here. And yes, you always want to review your trajectory report. This is incredibly important to verify the trajectory results. So I'm going to open this up, and I am going to modify how this is displayed a little bit just to make it easier for those of you at home to read. So I'm going to change this to an outline view, and we're going to begin. So for the project name here, that's going to be the name of our cycle. If you look for processing mode, you will see it is the Infusion single base. Remember yesterday when we were looking at that QC only, it stated as unprocessed. So this is our process point cloud, our trajectory. We're now going to click on the rover data QC section. This is where we just verify that there are no cycle slips during our flight. Remember, the cycle slips are where you completely lose connection with your satellites. So these little red dashes here at the beginning of our mission, that's where the sensor is turning on, so it's not going to be connected yet. We do have a couple here for a few of our satellites, but they do not go all the way down. We have at least 3 solid green lines at any one time, so this is a good result. We're then going to go to our smooth trajectory information. We're checking to make sure this appears to follow our flight path. It does look like it may have trimmed a little bit off here, but sometimes that happens in the report, but does not actually trim it out of our data later on, so we can verify that later. But this does appear to follow our path. We're going to check our altitude to ensure this appears at the flight height in our planned mission, which was about 70 meters, so this appears correct. We're going to go down to our total speed, and as I mentioned yesterday, it will trim out that first heading alignment maneuver, but you should see that second one here at the end. Okay, so that's just to verify that that was performed. Our next step in reviewing this trajectory report is to go down to our GNSS QC section. So this is where we actually verify that we have a successful trajectory solution. Now, what we're looking for here when you see solution type is you're looking for fixed. We want this as close to 100% as we can get. In this case, we are at 100. That's fantastic. If you notice you have a float or no solution, that means there is going to be some kind of degraded trajectory in some area of your flight, and that can be very problematic. So you would end up looking at the graph right below it. This stands for the number of satellites visible in your solution. So if you have a float or no solution, you should notice these lines at some point will drop down to the bottom of your graph, indicating that you have lost connection with those satellites and you will have degraded solution there. If it is at the end or the beginning of your flight, you can actually use this time interval here at the bottom, reprocess your trajectory with those specified times. There's an override time range parameter that can be used to trim out those bad sections so that won't be included in your data downstream and end up impacting your overall quality. Now, the next couple of graphs we're going to look at is our forward-reverse separation. So instead of looking at the pattern here, we're actually looking at this axis. So what we're actually looking for is a small range of values. So for this example, let me zoom in a little more so you can see that a little better. This goes from negative 0.03 to 0.17. That is a small range of values. That is perfectly acceptable, especially considering they bounce around mostly right here, except at the end of our flight. That's good. For our PDOP, what we are looking for is a range of 3 values. A range of 3 would be 1 to 4. In this case, it goes from 1.2 to 2.4, and for the most part, it stays within 1.2 to 1.35 until we are flying back home. That is perfectly acceptable. I am satisfied with this result. There is one more graph we do want to make sure that we check, and that is going to be the estimated point or position accuracy. Again, instead of looking more at the pattern, we are looking at our range of values. Again, we want this to be a very small range. So this one goes from 0.008 to 0.042. That is a very small range of numbers. This looks fantastic to me. I am happy with this result. We are satisfied with this result. Okay.
Are there units on this?
So these are arbitrary, or they're relative to themselves, so they're not necessarily units. I want to say this one is in meters, I think, down here for the position accuracy. But like, for instance, like the PDOP, it's relative to itself, yeah. And then I think the forward reverse separation is also in meters. But typically I'm just checking the range because all these, you can see them listed down here. Also trim out my explanation of that in case I was wrong. I do not want that in the recording. Okay. All right, so I am going to go ahead and complete our second trajectory processing job so we can do that same review, and then we can geocode both of our point clouds at the same time. So I'm going to click complete on this PPT job, so that's our trajectory processing. Yes, and yes, I want to review that report. And I'm going to do the exact same thing I just did, so I'm going to go a little faster. So I'm going to click on my outline. I'm going to zoom in here so you guys can see a little better. Here is the name of my flight. It is processed through single base. I'm going to go to that rover data QC, looking for those cycle slips. I have at least 3 solid green lines at any one time. That's fantastic. I'm going to go to our smooth trajectory. This does follow my flight path. That's good. My altitude is roughly 70 meters. That's what I expect to see. I'm going to go down to my total speed. I can see during my mission, so that's what's going on here, that it is sticking at 5 meters per second, which is what I planned. And then we have those heading alignment maneuvers at the end. That's great. Down to my GNSS QC section. My fixed solution is at 100%. That's what I want to see. And just to verify, I am looking at my number of satellites visible, and I can see that none of them drop all the way to the bottom, so I did not lose connection with satellites. That's good. My forward reverse separation, again, we're looking for that tiny range of values. So this goes from negative 0.0035 to 0.009 through our whole flight. That is fantastic. That is a very tight and accurate collection. For our PDOP, again, we're looking for a range of 3 or less. This goes from 1.235 to 1.4. Again, that is fantastic. Now to our last chart that we're going to check. This goes from 0.006 to 0.0165. Again, very small range of values. That means our point cloud is going to be very accurate from this collection. So I am satisfied with my trajectory report. Now that we have verified our trajectories, we can complete our geocoding jobs and get those point clouds generated. So I'm going to select one of these, but you'll notice when I click complete, it will actually let me know that it has identified 2 jobs of the same type and is asking me if I would like to complete both of them at the same time. In this case, the answer is yes, and it will finish geocoding and adding those to my table of contents at the same time. There's my first one, and my second one is complete. Does anyone have any questions at this time? All right, now that our point clouds have been added to our table of contents, we can now begin to investigate to see if we need to run strip alignment. Remember, strip align is intended to correct any inconsistencies identified in the trajectory. So separation between your flight lines, things of that nature. Now, yesterday we did use the profile view to do this. I am going to do that again. And just for a quick display, I will also run that surface precision tool just so you can see what that looks like. So I'm going to zoom in on my rooftop here. So something with a gentle slope of a planar surface is really good for these type of assessments. But if you don't have a building nearby, you could also use a vehicle or something like that. You want some kind of vertical object to check those separations. But I'm going to look for my profile view up here. I'm going to draw from one side to the other on my roof, but instead of dragging to specify my depth, I'm actually going to right click because I want to specify a very thin profile so I can really see the definition of this. So I'm going to do 0.3 meters. That's going to be roughly 1 foot. Okay. Now down in my display, I'm going to change it over here. So in this little drop down, if you hover over these, you will be able to see the name, but we're looking for the one that says point source ID. That is going to be the ID associated with each individual flight line. So once I click that, I'm also going to increase my point size. This part is entirely optional. It's just so that you guys can better see my screen. So let me change that to 4. That way these colors will really pop out. Now what we're looking for is if our colors all mix together or if they're distinctly stacked on top of each other, or you can see space between them. In this case, it does look like they are stacked right on top. They're not mixing together, so there is some kind of inconsistency here. There is some separation between our flight lines, okay? If we change to our other active LAS, so I'm looking at the one ending in 4.9. If I switch over to the one with 3.8, once again, we'll see where they're stacked on top of each other. They're not mixing together. We again have that separation here, okay? If you would like a better estimate on what that size is, so you'll notice here we do have some height, our measurements as well as along the bottom. But let's say I wanted to be able to look at these by 1/10 of a meter. I can click on my graticules, this little square box here, this little grid, but I'm going to hold Control when I do that. That will allow the settings to pop up for you to modify them. So up here in my quick grid, I can actually type whatever size I want and click refresh, and it will actually populate both of these at the same time. So it'll change the value and it'll also change it to the map units versus that number of lines there. Okay, so this is what I want it to do. When I click OK, you should see it is now modified. So each one of these is going to represent about 10 centimeters. Okay, so that's going to be, 1/10 of a meter. So in this case, on the cycle ending in 38, it looks like it's about 1 box width between these. So that's going to be about 10 centimeters. If I switch back to the other, from the very bottom to the very top, looks like it's a couple of those boxes, so that's probably going to be, about 20 centimeters. Regardless, since there's not a big gap between these, I'm going to assume the separation is less than 10 centimeters because I'm going from the top to the bottom, but we're really looking for where that gap exists, not the entire point cloud measurement, okay? All right, so now that I've assessed that, I could go ahead and run my strip alignment, but like I said before, and you guys are more than welcome to just watch for this part, I am going to run that surface precision tool very quickly to assess what these look like. So on my QA/QC tab, we're looking for surface precision. Now you're going to notice that this is grayed out. That is because I have not checked out my strip alignment license yet, and I've not clicked on the tool. If I click on the strip align tool, it will automatically pull down that license if it's available to me. But in this case, I'm going to go check it out manually. I can do that either by going to the support ribbon to find the license manager, or I can go to File and find the license manager here, which is what I'm going to do. I'm then going to find my strip align license. So here it is right here. I'm going to check that out, close it. It should take just a moment for LP to refresh, and then you'll see this tool is now available to me under the strip align license. So I'm going to turn this on. I'm going to tell it to use my planar surfaces only. So I don't want it looking at those trees, because remember, the trees are going to have dynamic movement. It's always going to be flagged in red. So I want to try not to look at those. I'm going to choose my overlap areas. So it'll look at where those flight lines overlap together. You can also do by flight line individually or globally. So it'll look at the entire point cloud. For this assessment, I just want it to generate one, so I'm just going to choose the overlap at this time. You can give it an output name. So I'm going to say cycle underscore, and I'm going to use the last 2 digits of the cycle to identify which one this is for. We can specify our cell size. So this is 0.3 meters. I'm okay with that. I'm going to leave it as is. And I want it to be colorized. So I want it to actually use the green, yellow, and red color versus a grayscale. So it'll be a lot more distinct. Now your pass-fail threshold can be specified here. So you'll see mine has chosen 2 centimeters by default, but you're more than welcome to customize that or to choose one of these other options. I'm going to stick with the default here. And if you would like to modify your colors, you can actually do that in the advanced settings. Click on the one that you enabled, so mine was the interswath, and you can see my different colors here, okay? So the interswath range is going to be a little bit different because it is looking at a specific area of your project. It's not looking at all of it. Versus, so you'll watch this, I'm going to enable global just so you can see this. In the advanced settings, this is actually holding strictly to that pass-fail threshold, okay? Okay. All right, so I'm now going to click process, and it is going to generate this raster for me. Shouldn't take too terribly long. Here we are. And it looks like it added it to the top here. So I'm actually going to close my profile really quickly. Let's turn off this point cloud underneath. And you can actually see the spots that it's picked up. So we see a lot of orange and a lot of red. Okay, so it looks like it didn't get my entire roof, so that means it's so fuzzy it thought it was vegetation. Okay, I could run this exact same tool again, but disable this, or I can just click global. In this case, I'm going to try global. We're going to see what those results look like. And you will see when it generated this little abbreviation stands for the surface precision, and that's actually the one that I selected. Okay, so in this case, I'm going to do global. I'm going to change the name again, so cycle underscore the last 2 digits, which is 49. I'm going to colorize once again, but you'll notice I did not choose this option. I'm going to let it look at everything. Process. And now we can literally see everything in here. Now, like I said, the vegetation is in that dark red. It's almost always going to look like that because it's going to have movement during our flight. But we're also seeing that on our parking lot. We're seeing it on our rooftops. We're seeing it on our cars, things that are stationary. So in this case, this one definitely needs strip alignment, okay? I could do the exact same thing on the other one. I could just switch it over, but we already know that we need to run it based on our assessment. So back on my sensor tab, I'm going to click strip align. I'm going to click both of my point clouds to use for input, because remember, they are overlapping, they are contiguous, so we are able to use them as input. If they were in different locations and they did not touch, we could not do that, okay? I'm also going to use the small misalignment because between the flight lines that I saw in my profile view, it only looked like about 10 centimeters between them. So that's the one I want to use. And I'm also going to modify this name because it can get a little long. So this is just going to be my strip align. Okay, that's all I'm going to call it. I'm then going to submit this. It's going to send it off to the job manager for processing. So it's asking me to confirm that this is what I want to do. The answer is yes. And we can now monitor that status in our job manager. All right, so it does look like my job has completed. For those of you that it has not, that's perfectly okay. I'm just going to go ahead and start reviewing these results. So I'm going to select my ready job here, click complete, yes, and it will generate an entirely new point cloud with both of those cycles merged together with the corrections in place. So I'm going to click OK here, close this out, and now I'm going to both look at the profile like I did before, and I'm going to run surface precision again to see how those results have changed. So like before, I'm going to draw from one side to the other on top of my roof. Right click, and 0.3 is the width that I'm using. If you decided to drag and select, you can also change that depth in here in the profile view just by clicking this little tool here, and you can specify whatever depth you would like to use. Now I am going to zoom in just a little bit to get a little tighter on our rooftop. So now you can actually see where all those colors are mixing together. We're not seeing two distinct colors stacked on top of each other. Now if I toggle between my active layers, so I'm just going to switch to the other ones, we can start to see that distinct separation, those distinct colors on top of one another. Now check out the last one. We can see that same kind of pattern where the colors are on top of each other. They're not mixed together. They're not aligned. But when we do our final one, we can actually see that nice alignment. Okay. Now just to review the results as well using the Surface Precision tool. On the QA/QC tab, Surface Precision. I'm going to do the global again because I really like the way that one displayed and showed us all the information. I'm going to do that colorized pass-fail threshold of 2 centimeters. Process. And now we have a lot better looking results. Now it does look like there are still a few areas that it may have struggled a little bit. So we could always try to run maybe the large misalignment, see if that made some different results. But we're also going to run another task called smoothing later on that may actually help to get us within that range that we're wanting to see. Does anyone have any questions at this time? In areas with a lot of change in elevation too, like the edge of your buildings and things like that, you can also see that the Surface Precision will pick up on that, and that can also be one of the reasons why it's saying, oh, it's really fuzzy, because it's actually seeing the wall itself on the buildings and things like that. So, all right, so now that we have performed strip alignment and we have seen that it did significantly improve it, we're also going to do our accuracy estimation. So I'm going to turn this off, turn that off as well, so that I'm just looking at the point cloud. And on the control points ribbon, I'm going to import my checkpoints just like we did yesterday. So here we're going to go into import. We're going to go into add. And I want you to find that folder I gave you yesterday labeled December Training. Inside of that one, you will see a control folder. Okay. Inside that folder, I want you to look for the text file. Okay. This particular dialog can take text, CSV, and other such ASCII type files. We're going to click open, and we do need to specify an output location. So I'm going to click my gear icon. I'm going to go into my project folder, so December Training, Day 2. This is the one that I've created. And I'm going to create a control folder to add all of my control information into. Now, you'll also remember, as I mentioned yesterday, that I use the exact same folder structure in all of my projects. So whether I come back to it in a week from now, I come back to it 3 months down the line, all of the information will be stored in the same format, so I and my colleagues can find it. Sorry again, didn't mean to. So I and my colleagues can find it. There, that way you can cut out where I smack it. And you can cut that out, sorry. All right. We're then going to select our folder. Onto the next tab. It is a delineated data set. That means there is some kind of special character or something of that nature indicating the individual columns. Now again, if you are using your own control point ASCII file and you have a header column, so one that actually tells you what all of the columns represent, you will want to change this import number to 2. That way the header is not included as a record. Here at GeoQ, we do not have a header column, so we are able to actually import on our first line. On to our next page. This is actually where you tell LP360 how your data is separated out. That's going to be using the commas, and you'll see it snap into nice, neat columns. On to our next and final page. This is actually where we assign the attributes to each of our columns. If anything is left as unknown, it will not be imported, okay? Now, I'm gonna review these as I go through. So my first column has a whole bunch of numbers and followed by letters. Since this column includes letters, it cannot be an ID field. It must be a name field. If you choose ID, it will cause an error later on in your processing. So column number 1 is name. Now for your coordinates, we make the assumption that you know which is X, Y, and Z. So in our case, column number 2 is Y. Column number 3 is X. And column number 4 is Z. Just to repeat that again, column number 2 is Y/northing. Column number 3 is X/easting. And column number 4 is Z/elevation.
Are we selecting the sigma 1, Y?
No.
Oh.
Y/northing, X/easting, Z/elevation. For column number 5, if we slide over down here, we can see this is a bunch of abbreviations. These are going to be our different types of targets. Each one of these will tell LP360 how to treat that target. So it's very important that you include this type field. So column number 5 is type. Finally, for our column number 6, if we slide over once again, we'll see there are a bunch of zeros and small values here at the bottom. Now, for our accuracy stars, which you can see listed here, for those of you at home, yours would have unique H offset values that you would measure out in the field because you would be setting those up on tripods. However, here at GeoQ, ours are on permanent poles, so they need just a small offset to account for where the antenna sits on top of the target. So that's why you're only seeing these very tiny little values here. So column number 6 is H offset. Okay. Once I have all of these selected, you can then click Finish. I will pause to make sure everyone's able to import them. Give me a thumbs up if you got it. 1, 2, 3, perfect. Right. Once these are imported, you are more than welcome to modify the name and symbology of these. Because you can see the name is a little long here. So if I wanted to, I can select my layer, and this goes for any layer in LP360. Click the name again, and I'm able to actually modify this. So you could change it to control points. If you would like to change your symbology, you can also do that by double-clicking on the symbol itself. You can change the type of symbol. So I actually like to use the crosshair. You can make it bigger, so you can make it as big as you would like. You can also increase the width to make it really stand out against the background, and you can even change the color. So if you wanted something more like neon or something like that, so if you wanted to choose pink, blue, green, any of those colors are more than acceptable. Click OK, and OK once more, and you should see those colors appear in your map view. All right. So there are a couple different ways to start navigating through these, because remember I mentioned if you have any vertical objects near your targets, you are going to want to do your ground classification before doing this assessment. So a very quick way of assessing those without ever opening the dialog is I can zoom in on my targets, so you can actually see it right here. I'm going to change this to a 10 surface, just like this. I could also change it to elevation if I wanted to see if there was anything vertical around those. So if I click elevation, you'll see this is nice and level, so I'm not worried about anything around this target. I can then use these navigation buttons to actually drive through the different targets. So I can just very quickly click through. We're looking for any change in elevation that might be an object near our target. Okay. The only one we should actually see anything vertical next to, so you can actually see right here, this is going to be some grass. If I wanted to see where it was in relation to my target, I could change back to color, and it looks like it's pretty far away, so I'm not really worried about that. Okay. The only target that should actually show elevation change is our accuracy star. All the others should look flat and level. Okay, so there's our accuracy star right there. All right. So now that we've verified there's no vertical objects near our checkpoints, we are now able to begin our vertical accuracy estimation. And in this case, since we have those 3D targets, our X and Y as well. Yes. All right. So now we're going to go into our accuracy estimation tool. Now that we've verified that there's no vertical objects. And remember, our yellow icon is letting us know, hey, stop and read me. It's letting you know that we need 5 different columns. So those will be type, H offset, accuracy X, accuracy Y, and accuracy Z. It will always need to create those last 3 so it's able to actually do our measurements. So I'm going to click continue and the dialog will appear. So this first pop-up here is about our survey method. It is entirely optional. It does not impact our data. It just gives us the expectation of accuracy for our measurement method. So for example, if I do my base and rover, this is the level of accuracy I can expect for X, Y, and Z. If I do the closed loop and digital level, this is the level I can expect to see, or you're more than welcome to leave this as blank. Okay, it's just to give you an expectation of your particular survey method. So I'm going to click OK here. As I mentioned yesterday, you can go into your settings to modify those. So for example, if you had a different size checkerboard target that you were using, or maybe you wanted to modify your search radius, you can do that. You can also modify your input points filter if you needed to do your ground classification before this step. You could specify that here so it will not use all those other points. Okay. For this exercise, we are going to leave these as default, so we're going to click OK. And I'm actually going to disable my accuracy stars because I'm going to use those to verify my results or check my results after we've done this. I could also do the same thing for, say, my painted targets. Maybe I wanted to use those as checks too. So anything with an FK marked by it, I'm going to go ahead and turn those off. So it looks like I have 2 FKs, 2 painted targets. Okay. After that, I'm going to click Auto Find. This pop-up here, this disclaimer, it is letting you know that this report is not a guarantee of accuracy. It is a statistical representation of accuracy based on the ASPRS standards. So I'm going to click OK here. Since it did detect these target types, AS, accuracy star, CB, checkerboard, and or CO, concentric circle, it is telling me I need the 3D accuracy license in order to calculate X, Y, and Z. So it's asking me if I want to check it out. The answer is yes. It has one available, so it's going to check it out for me automatically and then begin the calculation process. All right, so it does look like it went ahead and turned off some additional targets for me, but we're actually going to go in and inspect those to see if they're actually wrong or if they're just statistically different than our surrounding targets. Okay, because when they're turned off, they're based on these colors up here. So I'm going to look at number 11 here. It's colorized in pink. That means it falls on the outer 10% or exceeds the 90% of the confidence interval. Again, that just means it statistically looks different than the rest. So what I'm going to do is come into my map view. I'm going to change my elevation or change my display to RGB. I can't really see what's going on here. I can also change it to intensity because we are using black and white targets. If this one doesn't appear, that does mean something happened to this target, whether it got moved or damaged or something like that. So it was actually very good that this one turned it off because it is not able to actually estimate that center. The target's not there. So we're going to turn this one back off. We're going to go to our next one. So here's that next checkerboard. And now you can actually see those black and white spots. And you can actually see this green checkpoint actually indicates where it identified the center. So for example, if it did not do a very good job of identifying that, I could use measure mode, but we typically recommend using measure mode when you have an ortho mosaic in place. So we have not processed our orthos at this time. I will submit those in just a moment after we've done this assessment. That way you can see the differences in the types of orthos available through LP360. Now, statistically, I do think this one's doing a pretty good job of falling relatively in the center of that target. So I actually want to turn this one on. You will see it automatically populates with new values in your measurement when that's enabled. So here's one more checkerboard that it was turned off. So here's another one. I can actually see the black and white. Again, you can turn that to RGB to see if you can see it a little more clearly. But the intensity value is actually recorded by the sensor itself. So again, I could turn this one on, see how that represents my surface. Now you will see there are a couple ones that it did also highlight in pink for our concentric circles. So we can actually see those there. Let's switch the intensity, see what that looks like. So if we were dissatisfied with the way this target looks, like if it looks damaged, if it looks incorrect, you can turn that off. But again, you would want to inspect these in your Ortho mosaic to get a better idea of what they actually look like and what's going on. All right, so I've now looked at this. My accuracy is pretty good, but I want it to be better. So what I'm going to do is do my auto-find, or not auto-find, apologies. What I'm going to do is actually use my solve button to debias this data set and generate a new point cloud. So I'm going to click solve. These are the values that it is decided to use based on the mean error and the standard deviation. So what these values represent, so RMSE, that is your root mean square error, that is the measure of accuracy. Your SDOM, or standard deviation of the mean, is your level of precision, and the mean error is just the mean statistical representation of error across all your checkpoints. So it's actually going to use this mean error and standard deviation to figure out what's going on. Okay. If your standard deviation is very, very small, so in this case it's less than 1 centimeter, it is not going to modify these values. It's just going to stick with that mean error because it means our data is very precise. It's just a little inaccurate. So that's what it's going to debias by. So I'm now going to click Apply Corrections. It will begin that generation process of our new point cloud. Okay, so it looks like it did add my new layer over here to my table of contents, but before I close this out, I'm actually going to click Export Report because I want to make sure that I have a record of my corrections that I made. So I'm going to click Export Report. There's my December folder. Here is my project folder. Here's my control. And this is going to be my control report OG for original. Click Save and click OK here. Now it is asking if you would like to save the changes to your attributes in this shapefile. The answer is yes, because it's saving those errors that it calculated. So I'm going to click yes. All right, now that that's done, I'm actually going to rename this one so it's easier for me to identify what it is. I'm going to select the layer, click it, the name, and now I'm going to rename it Strip-Align _ Debias. So I know every step that was performed on this layer. Okay. Now that that's done, I'm going to change it to my active LAS layer here. Looks like it's turning on this underneath. I don't want that. And now I'm going to go back into my accuracy estimation, but I'm only going to turn on my accuracy stars and my painted targets. So those are my checkpoints, the ones I just turned off. So in here, I'm just going to click OK. We're going to leave that as is. If you wanted to turn all of them off at the same time, you could actually select, go to the bottom, hold the Shift key, select all of those, click, and it'll actually turn off everything in between. So it's a very quick way you can do that. Here's my other painted target, so I'm going to turn that on. So we only have our FKs, so FK, and our AS, or accuracy stars, enabled. We're now going to verify our results. So I'm going to click Auto Find here. Again, this is the disclaimer telling you this is not a guarantee of accuracy. It is a statistical representation of accuracy based on the ASPRS standards. I'm going to click OK. It will perform that assessment. And here are our new accuracy measurements. So we can see our vertical significantly improved, and I think there was a little improvement in our X and Y, but it's not measuring X and Y for our painted targets, only for our accuracy stars. So remember, that's only going to be 5 targets. We may not get a full picture of our entire point cloud because you do want to use as many as possible. But just to compare my results, I'm actually going to export my report. And this one will be my control report _ Debias. So I know which one this is. Click OK here. And I can actually go into my File Explorer to go find those. So in my training folder, December, here's my day 2 control. I actually like to open these up in, it's called Notepad++. It actually allows you to compare multiple against each other. So I'm going to open up my original, make sure that's the only one open. Now I'm going to open up the second. Now you'll see both of them are open side by side, but I want to compare them. This is an extra step that does not have to be performed. This is just to demonstrate the changes between these two. So I'm going to come find my compare button right here. You can see it also tells you the version of LP that was used, who generated it on what machine, the time and date, the units, the surface method, all that good stuff. And now here are our results. So for our original, it looks like our X did not change at all, but our Y did actually improve, and so did our Z, okay? We can also see that our overall accuracy did improve as well, from about 7 centimeters to about 5 centimeters overall. For our Z exactly, it's going to go from about 3 centimeters to about 1 centimeter of accuracy, is what we're seeing. If we scroll down to the bottom, we can actually see which ones were turned off and which ones were turned on, okay? We can also see that there was one control point that was turned off in both. Okay. So now we have a full picture of everything that was done during this assessment, including all the values for each individual measurement during the assessment as well. So all of that is stored in your reports. Does anyone have any questions on what I just did? Like I said, this part where I'm comparing these is entirely optional. You do not have to do this step. I just really like to do it so you can actually see the differences in your two reports without having to toggle back and forth between them. Okay. So looks like we don't have any questions. So now that we've done that, I'm actually going to close this out. I'm satisfied with this new debias layer. But for the sake of this video and for you guys, I am going to run both the Agisoft ortho mapping tool and the ortho mapping tool, so we can view both of those results separately. You guys do not have to execute these alongside with me. I'm just going to go through what I would normally do in this instance, but I am going to let it generate its own DEM versus generating one myself. So you can also see what some of the effects would be on your point cloud if you just feed it the raw point cloud without doing that DEM yourself, okay? So I'm going to start off by doing my Agisoft ortho mapping tool. I'm able to click on this and open it up without checking out a license because it will do it for me as long as one's available. If you do not have a photo with Agisoft, also called the photogrammetry with Agisoft add-on license, it will not let you open this. Additionally, I do not have a Metashape key active on my machine, so I'm going to run this one through the cloud. Okay. Now, once it's done that, I can either select one or both of these images. In this case, I'm just going to select one. So I'm going to choose the one with, we'll do the one with more photos. So that's the one ending in 49. I'm going to click Generate Point Cloud or Ortho from Images, because this other one's where it's trying to pick that DEM. I did not create one. I don't have one to give it. And I'm just going to check for it to generate my ortho. I'm now going to give it a name. So just for simplicity's sake, to know which one I did, I'm just going to do cycle underscore the last 2 digits of the cycle I selected, which is 49, underscore ortho. Okay. So as for the rest of the settings, I'm going to leave them as default, and I'm going to go ahead and submit this off to my job manager. All right, it will give me confirmation that that has been done. And now I'm also going to run the ortho mapping tool. So this one is the one that creates that RGB map, also referred to as a fast ortho. So I'm going to choose any one of my layers that I want. I'm actually going to choose my Debias layer here because it's working off the RGB. I'm actually going to let it auto compute my cell size as well. And I'm going to specify the name down here. So strip align Debias underscore RGB map. That's what I'm going to call it. So that way my orthos have two distinct names. I'm going to click create, but unlike the Agisoft ortho mapping tool, this one will run in front of you. So if you do decide to run this and you do have a large data set, it can take some time and it's going to keep you from processing anything else during that execution process. So do keep that in mind if you choose to execute this one. Now, this one also requires a different photo license, so either Photo, Cloud Photo 3000, or one of the legacy licenses, which is referred to as Full Photo or Fast Photo. All right, so that did run pretty quickly, but I do want you to check out these results. So if I go all the way out, so I'm just going to go to my full extent, it does look very clean. I can actually see some tire tracks and things like that down here. However, if I start to zoom in on some objects, you'll start to notice this is very pixelated. So this is not intended for the high quality photo level generation here. This is more for something quick and dirty, so you just are able to visualize that colorization in a raster format. Okay? If you're wanting that high quality resolution, you will want to go with the Agisoft ortho mapping tool.